Okay, here comes problem number 7. Number 7, I actually started doing this problem without a calculator, and then I realized that it gets pretty into the weeds if you try and do it without a calculator. So I'm going to do it with a calculator now. And when I did it originally, I did it without a calculator, so I might stumble a little bit as I do this, but I'll try my best. Okay, so let f of x equal this function right here between 0 and 6, and they give us a picture of it right here. Let R be the region enclosed by the x-axis and the curve of f. Find the area of R. Okay, so we need to integrate, and we're going to integrate x parentheses x minus 5 squared dx. But then we need to go from where to where. So it gives us that our domain is 0 to 6, but this is a little confusing because we don't want to actually go to 6. We want the region enclosed by the x-axis and the curve. So if you actually graph this, because when I first did this problem I was thinking, oh, I should go to 6, but if you actually graph this function, you have x parentheses x minus 5 squared. If you graph it, it's a cubic. And so if you look at the graph, you'll see that after the 5, it continues up forever. So if we're talking about the region enclosed by the x-axis and the curve, the x-axis and the curve, the only thing that is enclosed by the x-axis and the curve is this area in here, up to this point right here. So it looks like I'm going from 0 to 5. But just to make sure those really are the points, what I'm going to do is I'm going to find the value at when x equals 0 and see if that really is the intersection. Yep, it is. So it starts at 0. And it looks like it's ending at 5. So I'm going to see what happens when I put in for the value x equals 5. Let's see if I get a, oops, I got the glare going there. If I put in 5, do I get 0? Yeah, I do. So it has an x-intercept. It's 0, 0, and 5, 0. So I am going to integrate from 0 to 5. So we set up the area. Notice this says it's 3 points. So you're getting 1 point for setting up the integral, 1 point for getting the boundaries correct, and then 1 point for successfully doing it on your calculator. So now I'm going to integrate it. So on my calculator, option 7, my lower boundary is 0, my upper boundary is 5. There it is, and I get 52.1. If I'm rounding that off to 3 significant figures. So that was 52.1 is my area. So that would be units squared. I need to be careful what it's asking for. Since it's asking for area, I want square units. If it was asking me for total distance, I would just put like meters or units, whatever, but not squared. Okay, find the volume of the solid formed when R is rotated around the x-axis. Okay, so remember these formulas are in your formula packet. Okay, so if you forget, volume is in here. So see how it says pi y squared? That y is the same as f of x. Okay, y is the same as f of x, and it has to be squared. And you see where they put the pi? I don't like putting it there. I like putting it on the outside. So volume is equal to, I like writing pi times f of x squared dx. Okay, that's how I like writing the formula. All right, so I know my f of x, so I'm going to put that in, but I need to square it. So my volume is going to be equal to pi times the integral, again, from 0 to 5, of x times x minus 5 squared. And that whole thing needs to be squared. Okay? In order to get the volume, I need to rotate it all the way around, making circles. And remember, formula for the area of a circle is pi r squared. That's where the volume formula comes from, pi r squared. There's my pi, my radius. My radius is my y values. So remember, we rotate those around. Remember the video? If you don't remember the video, go watch it again. It is attached to one of your assignments. Okay? It's squared. Radius, the radius is the function, gives us the y value, and we square that because that's our radius of our circles that are being created. Okay, and dx, just to write it correctly, and then I'm going to put that into my calculator. So I am going to, I can square this, well actually no, I can just put this in. All right, so I'm going to go to y equals, and I'm going to have x times x minus 5 squared, and the whole thing squared. So notice I have parentheses around the whole thing, and that is then squared. So I can graph that. And then I'm going to integrate that, number 7, from 0 to 5. That gets me, so just the integral part gets me 744. But then I got to multiply that by pi. Okay, I'm going to have to multiply that by pi. I'm actually going to write down, let's do it like this, 744.04762. I'm going to write down all of it, and then I'm going to multiply that by pi. So I don't know how to get it from here to the other screen. I'm sure some of you have probably figured out how to do this another way, but I'm just going to type it in again. So I'm going to have pi times 744.04762. I don't want to be off at all, so I put the whole thing in, and then I get my answer. That would be 2, 3, oh, this is funny. I got a different answer this time than I got before. Shoot. What did I do wrong? So right now I have 2, 3, 4, 0 if I'm rounding it off to 3 significant figures. And I am going to take a break for a second because I think I might have made a mistake because I got 2360 before. So what did I do? I'm going to take a break. I'll be right back.